What's the actual commodity in the world of artificial intelligence? I mean, when we talk about ChatGPT, Gemini, or Claude, what are they really trading in? It's not oil, not electricity, not even data. It's something smaller, stranger, and far more valuable: the token. Welcome back to UTC AI Studio, AI-powered, creativity-fueled. Today, we're pulling back the curtain on the hidden language that powers every AI system and the new form of currency that's driving this entire technological revolution. So let's dive right in. Think about it. You type something into a chatbot, maybe ask it for a story, and what you get back is amazing, coherent, creative, sometimes even funny, and feels almost human. But have you ever stopped to wonder what's actually going on inside that black box? How does a machine, just circuits and code, understand something as abstract as a word like brave? Well, the answer isn't what most people think. AI doesn't actually read English or Spanish or any human language. It has its own native tongue, a secret internal code completely hidden from us. And understanding that language is the key to get an idea how intelligence itself is built. When you get right down to it, under the hood, every single AI model breaks our world down into tiny, fundamental pieces of data. These pieces are called tokens, and they are the true building blocks of artificial intelligence. So, what's a token really? It sounds simple, but this one little concept is incredibly powerful, and it has some surprising quirks. The very first thing that has to happen inside an AI is a process called tokenization. You can think of it as a translation step. It takes our human data, whether that's text from a book, a photo you took, or even a clip of your voice, and chops it up into manageable pieces the AI can actually work with. A good way to picture it, think of tokens like atoms. Just as atoms are the basic building blocks of everything around us, tokens are the basic building blocks of how AI understands the world. Let's look at a real example. Say we give the AI the phrase, the word darkness. You and I see three words, but the AI might see it differently. It could break it down into subwords, dark and ness. Suddenly our short phrase is now 4 tokens: the, word, dark, and ness. But hold on, chopping up words is only half the battle. At the end of the day, computers don't speak word or dark or ness. They speak numbers. So the next logical step is to turn all these little text tokens into something the machine can actually work with. Each one of those tokens gets assigned a unique ID number, kind of like an entry in a gigantic digital dictionary. Now here's where the magic starts. The AI later encounters another word, brightness. It splits that up too, bright and ness. And notice something cool. The token ness gets the exact same ID number as darkness, maybe number 655. By seeing that same shared token thousands and thousands of times, the AI begins to realize, ness describes a state or quality. In other words, it's learning patterns, learning meaning from numbers. To help visualize the scale of this, OpenAI gives a neat rule of thumb. For English, one token is roughly 3/4 of a word. So, if someone says a message is 100 tokens long, you can picture that as being about 75 words. Every chat, every image caption, every training sample, all of it gets broken down this way. But hold on, it's not quite as simple as it sounds. Let's say you use the word red. To us, red, a red, and red at the start of a sentence are the same word. To AI, they are 3 completely different tokens, each with its own ID. Why? Because for a machine, context is everything. The lowercase r, the capital R, even the space before the word. Every tiny variation changes how the token is defined. So when people say AI doesn't understand words like we do, that's literally true. It understands patterns of tokens, not words, not sentences, but sequences of numeric IDs that represent context. Okay, so now we know what tokens are. But how does an AI actually use them to do everything from writing essays to generating code? It all comes down to 2 phases: training, which is how the AI learns, and inference, which is how it uses that learning to actually answer your questions. During training, the model is fed a mind-boggling amount of data, billions, sometimes trillions of tokens, scraped from books, websites, research papers, and more. And the task it performs is beautifully simple. The AI sees a string of tokens, something like the cat sat on the, and its only job is to predict the next token. If it guesses mat and the training data agrees, great. But if it guesses floor, that's wrong. So it learns from the mistake, tweaks its internal wiring just a tiny bit, and tries again. Do that billions of times, and it becomes frighteningly good at guessing the next token. That's all learning really is, predicting what comes next in a sequence. Now, once the AI is trained, you and I interact with it through the second phase, inference, the part where it applies everything it learned to our prompts in real time. And this is where another key concept appears, the context window. The context window is the total number of tokens the AI can keep in its mind at one time. Think of it like short-term memory. When you start chatting, your question and the AI's response both get turned into tokens and stored in that window. As long as the entire conversation fits inside it, the AI remembers everything perfectly. But what happens when we keep talking? Eventually, you're going to hit the token limit of that window. As soon as you go past that limit, something strange happens. To make space for new tokens, the oldest ones get pushed out, and the AI literally forgets them. That's why, after long conversations, chatbots sometimes lose track of context or repeat themselves. It isn't that they're confused, they just ran out of memory space. The good news? The context window is getting bigger fast. Early models could handle maybe 2,000 tokens, a few pages of text. Modern ones process over 1,000,000 tokens, enough to read and analyze an entire novel at once. But bigger windows come with trade-offs. Double the size and the compute cost doesn't just double, it quadruples. And strangely, some models get worse at remembering information buried deep in the middle of very long contexts. So, as always, progress brings new challenges. Here's where everything ties together. Tokens aren't just a language for AI, they've become a currency. Every single token an AI reads or generates consumes computing power, energy, GPUs, time, and those resources cost real money. That simple fact has created the entire business model of modern AI. I absolutely love this quote from NVIDIA's CEO Jensen Huang, which frames it perfectly. AI heralds a new era of innovation, and now we have ability to manufacture intelligence. Think of these giant data centers as AI factories, and what product are they making? They're manufacturing intelligence. The raw material is data, and the unit of production that you measure, that you buy, that you sell, is the token. Companies like OpenAI, Anthropic, and Google charge for usage by counting tokens. You pay for input tokens, what you send, and output tokens, what the AI sends back. Summarizing a long document means lots of cheap input tokens, but only a few expensive outputs. Writing a poem flips that, few inputs, many outputs. So when you're chatting with an AI, you're effectively making a microtransaction of intelligence. You spend tokens to receive tokens. And those massive GPU clusters you hear about, they're the factories producing intelligence. Their raw material is data, the finished product is meaning, and the unit of production, the thing that gets counted, priced, and optimized, is the token. Even metrics inside AI development revolve around tokens. Time to first token measures how fast an AI starts responding. Throughput tracks how many millions of tokens per minute it can generate. Everything in this new industry, cost, speed, memory, even intelligence itself, circles back to one small unit. Of course, there's always a flip side. As context windows expand, so do expenses. Compute costs rise quadratically, and keeping trillions of tokens in motion demands staggering energy. There's also the question of reliability. Bigger memory doesn't always mean smarter results. Models can hallucinate, forget middle details, or even be manipulated through hidden prompts buried deep in the text. So efficiency has become the holy grail. Hardware leaders like NVIDIA have slashed token processing costs by 20 times with new GPUs and optimized software stacks. Because in the world of AI, making tokens cheaper and faster is everything. Okay, let's make this practical. Why should you, an everyday user, even care about what a token is? It really comes down to three things: cost, speed, and coherence. Lengthy prompt and response directly impact price. So more words in or out equals more tokens equals higher cost. Token processing determines how fast you get a response. So faster models equal quicker time to first token. And a larger context window equals better memory and flow in long conversations with more consistent answers. The next time you type a prompt, remember, you're not just asking a question, you're conducting a trade in the new economy of intelligence. Input tokens go in, output tokens come out. That's the invisible currency behind every conversation you have with AI. We started this journey by calling tokens the building blocks of language, and now they're the units of thought, memory, and even value. They're not just fragments of data anymore. They've become the way intelligence itself is measured, manufactured, and sold. It raises a fascinating question for our time. If intelligence can be priced per token, what's the cost of a thought? What's the true value of an idea in a world where machines can generate billions of them every minute? We are watching in real time the birth of a new economic unit, the token, and with it, perhaps the first true currency of artificial intelligence. Thanks for watching UTC AI Studio, AI-powered, creativity-fueled. I'll see you in the next video, where we will cover how do transformers work in AI. Till then, as always, keep learning, keep building, and keep creating with AI.